And while you're doing that, Shaminda, your talk is on redesigning the delivery of the laboratory exercises based assessment in response to COVID-19 restrictions in electrical engineering. Now, I know that you are a lecturer in engineering on our Bundaberg campus at CQUniversity. I wonder, before I start the 15-minute clock, I wonder if you just describe for us your research interests. You'll need to unmute.
Yeah, thanks, Michael. Basically, my research interests are based on biomedical engineering, and my base PhD was using electrical signals to diagnose sleep apnea using non-invasive techniques. So it's like at the moment, this sleep apnea is getting a little bit of a concern in most of the places, because it says like it leads to so many other conditions as well, severe conditions, especially dementia and all these kind of diseases. So that is my background, but at the moment I am doing research on electrical power systems as well as on solar and wide range of area.
Great. Well, it's a polymathic approach.
Yeah.
So look, your 15 minutes, please, and you're talking about redesigning the delivery of laboratory exercises, as we said now. Thank you.
Yeah, first of all, I would like to thank Professor Helen Henry, Associate Professor Celestin Lawson, and organizing committee via Maria and Shri, and also blind reviewers as well as moderators like you, Michael. So you providing your time in spending on this really worth course at this moment of time, because I think I'm the last presenter, so I thought of it maybe very well concluding remark for appreciation of your guys' work. And I'm Shaminda, and I'm from Bundaberg campus. I'm doing electrical engineering lecturer. And I have been teaching this unit what I'm presenting today for last 5 years, and involve like so many up and downs, and always I involved in continuously developing the unit material in response to unit evaluation, as well as using my own imagination. So this unit I'm going to talk about basically introducing, I think once you talk about engineering, there are three main disciplines in electrical engineering at this moment, like not at this moment, like from the very beginning. So what is called civil, mechanical, and electrical. So all other, like most of the other combinations we have, it's like kind of a combination or hybrid version of these three, or two mix of all three. So it's like if somebody asked me to explain what is the difference between these three main disciplines, I simply say civil is something visible and touchable, if anything related, like for example, building or bridge, or something involved in civil engineering, it's very clearly visible and you can touch it. There will be no harm in doing that, as long as material is not toxic. And the mechanical, if you look at mechanical engineering, what is mean mechanical engineering? If I explain in layman term, it's visible, but it's not touchable sometimes, because it has a lot of rotating parts. If you look at a machine, it's considered as a mechanical engineering. It's rotating. If it's not touchable. And unfortunately, for when it comes to electrical engineering, it's not visible, but it's not touchable as well. You can touch it, but you will be gone because you get electrocuted, right? So because of that, and this learning and teaching and learning always based on modeling. So because of that, this involves a lot of mathematical imagination, and it's very hard to teach. So that is why, so when it comes to electrical engineering, it's very difficult to teach and make students understand and learn as well. So it gives a very big challenge to lecturers as well as students. So the unit, when coming back from that one, the unit what I'm going to discuss today or implemented in term 1 in this year is electrical. The name of the unit is Electrical Component and Circuit Analysis. And this unit is offered to associate degree as associate degree unit in our university. And it is offered in online mode. And this one is offered in second year term 1, but this unit is more like a foundation kind of a unit for electrical engineering students. It is the basically all other following years content is built up on this unit. So it's very critical for all the students to get a very good foundation as well as good understanding of this unit. And because of this unit, as I said before, is mainly mathematical modeling, involved mathematical modeling. So, and as well as we use some software modeling as well. But basic thing is mathematical modeling, and we use a lot of software to model the circuit, the electrical circuits. So, as we know, most of our associate degree students, they are working, and there are reasons of education, like, you know, leaving high school far away from, and that is a kind of issue. So we had to bring them back to that upskill their mathematical skills as well. So it's kind of a hard task or difficult task for us when we are doing it online. So these are the issues we kind of in unit details. And if I looking at the content wise, so this the content wise of this unit, majority of content is very abstract in nature, and it is there are a lot of theoretical concepts very hard to teach or learn as well, and it demands very high level of mathematical understanding and application of mathematical concepts to these models, what we call modeling of the circuits. And on top of that, as I said it before, because this is visual and non-touchable, so most of the stuff we are doing on secondary evidence when we are developing prototypes. So hands-on experience is very important to consolidate the learned theorems. So that is kind of a challenges we face even without COVID-19 situation, right? So what's happened, how we did it in pre-COVID-19 scenario or in the previous offerings. So we conduct face-to-face residential school where we complete set of laboratory exercises. So that helps students to get on understand the electrical concepts and consolidate on their learning as well. So another thing what we did during the residential school, we carried out face-to-face lectures, tutorials before the laboratory exercises, where we can further their understanding of the concepts, and then immediately they go to once you finish the one lecture and a tutorial session, so then it is followed by the laboratory exercise where they get hands-on experience from that, and then after that they will be much more confident on applying those the theorems as well as solving practical problems when they face a problem in industry as well as in the uni as well. And what happened with the changing landscape of learning environment after COVID-19? So what we, as everybody previous presenters mentioned, so we cancel face-to-face contact. Because of that, we have to cancel the residential school as well. So that means we are deprived of that like great opportunity to conduct laboratory exercise on face-to-face, as well as conduct these face-to-face lecture and tutorial sessions with students because this unit was offered as an online mode from the very beginning. So, and as others mentioned, as presented, so that there was very short period or time frame to implement or find a replacement for residential school where we did carry out our practical hands-on exercises. And on top of that, this practical assessment was a key assessment piece of the unit, which contributes more than 35% from their final grade. So students are very worried in the very beginning, okay, how are we going to do this one? So that's also kind of a issue for us as well, because we had to make sure that we do a really good job, or whatever the solution we are coming up need to be really good replacement for the residential school. And we all started having a discussion. We started having a discussion for new delivery method to conduct these laboratory exercises, because that will be a key part of the assessment, as well as it's very important for electrical engineer to have that experience when they are going to the industry. As well as other thing is, on top of that, we need to make sure that we meet the Engineering Australia standards in our courses, so that we get the accreditation for our course, or we continue to have our accreditation valid for our courses. So that is another mandatory requirement we had to fulfill. And then, so then after that, so I had a chat with our discipline head, as well as laboratory technicians and all the other people who are involved in the head of the course as well. So what kind of a alternative solution we can find. So as well as we thought, everybody agreed that it is hands-on experience is essential for student learning experience, and we can't drop that out in any circumstance. And as well as we just sort of other thing is important things, we can't compromise student learning and teaching experience as well within this unit, because it will be really impact the other learning activities that they are going to do it in their next term or next year as well. And so we finally decided that we are not going to change laboratory experiments. We will keep it as it is and think of how to do these laboratory experiments without attending residential school or coming to a campus. So we thought of okay, let's look at what solutions are we putting. So we thought of what about transforming their own home environment into a laboratory setup where they can complete their laboratory exercise while they are sitting in a home environment. So that will satisfy the COVID-19 government regulations, as well as our objectives as well. So that's the one come up with the solution, the suggested solution. Then comes up, how are we going to do that? Because as we know, we have a lot of laboratory equipments in our campuses, and that's how we do it, and how we transform that into how we get that one done in home environment. So this is the method. So I would like to categorize this one into 3 phases. So that's one. First phase is how we can do is we do initiation, or if I call it initiation, and the next phase is delivery of the components, delivery of the lab equipment and instruments, lab components, and facilitation. So that will be the most important thing. We have to make sure the students are happy and they are confident in using the equipment, as well as they're getting all the learning and teaching meeting the learning and teaching objectives desired for this unit. So what we did was, firstly, we develop a component list and equipment what we need for this conducting these laboratory exercises in a home environment. This is, and we shortlisted, and then we was thinking about what are the characteristics need to be these, especially components are very small, like luckily for the electrical engineering practicals, the components are small in nature, like resistors, capacitors, and inductors. That's basically we are using, though, and wires. And so those things don't weigh more than, if you put it even 50 of them, it don't weigh more than a 50 gram, or maybe 250 grams or something like that. So it's very lightweight. So it's not a problem on that one. And then the problem comes with the equipment. So the criteria we were facing, we had to find some kind of a portable equipment, and as well as those equipments have to meet the need of the unit experiments, or they can, using those equipments, we can carry out the practicals, hands-on experiments. So component list was not a problem, and we developed that component list and the equipment list. So we talk about that, and that one, and this. And also we have to think in this situation when developing or developing our equipment and component list, how we have to think one step ahead, how we can send these things to the students, right? So the cheap and cost-effective way of delivering this one is make into a package and send it via post. So we thought of like, so that will be the best way of doing it. So we build up all these laboratory, find the list and purchase. And then, as other presenters mentioned as well, there was an issue with like purchasing this one on time. So luckily we were managed to find a good supplier, and we quickly take decisions, and we build up our we make the orders for the laboratory kit, and within 1 week we managed to get this all the equipment what we need. So that's kind of a rare thing, but we managed to do it with a little bit of a luck. So
we built. Shaminda, if you could sort of conclude in the next half a minute or so.
Yeah. So what we do is we collated student mailing address and delivered these via post. And what we do is other thing is in facilitation, we develop lab guides and also lab videos, conducted Zoom sessions. Especially normally we do it in the afternoon, but this time we did it in the evening. So I would like to say some of the lab kits we delivered to some online student living in Argentina during they caught up in the COVID situation, they cannot come. So she was successful in getting that. And then we did all these things using Zoom, and we did demonstration of laboratory exercises by our lab techs using Zoom. And the good thing is we found average mark was this assessment was around 86 point, and 80% of the students scored more than 75. And really students appreciated and acknowledged our teaching staff efforts, and that was reflected in unit evaluation as well positively. Yep. I'm done, and any questions?
Thank you. Thank you. You've reminded us, just even for those that invented the world we now live in, the teaching challenges are just as great. So that's nice to know. I appreciate it too that you talked about the student feedback and the fact that your efforts were rewarded with good feedback, and that's important to us. So I do want to finish up at about 12 o'clock. I do want to ask the question that Maria has posed. Before I wrap up and point to Alex's reminder about our polls, is there any questions for Shaminda?
I have a question, Michael.
Thank you.
Shaminda, how much did the kids cost? Was it a costly exercise? Was it?
Yeah, that's a good question.
On a long-term basis?
Yeah, it's like a little bit of because of what we did was we went for a kind of a software-based equipment, so it's a little bit cheap and portable, And so it costs in total package per student cost us around $400 to $500. And so actually what is a good thing was we were able to convince the head of the course as well as the discipline leaders that we can use this one more often in next offerings at the moment because of the success of what we have done. So they said that we may be going in this direction in the next offering as well. So that will be the long term, that cost per student will be go down drastically, I would assume.
Okay, thank you. Very interesting.
Great. Well, thank you very much to all our speakers, and particularly for their disciplined approach in presenting their materials.